Hello everyone, and welcome to lesson 5.4, which is on multiple inequalities. Now, multiple inequalities are two separate inequalities whose answers are written together into one statement. Now, in 5.3, at the end, we looked at the OR version of some compound inequalities, how we have two separate inequalities like layered up and they're going in different directions, and we express those with an OR. In this case, we're going to look at a different version of that. These are considered AND problems and how they are written. And at first glance, they look like they are kind of crazy, but once you break it down and you can see what's going on, it makes more sense. So our example of having two inequalities written into one statement is written here in pink, and you see that we have -3 is less than x is less than 8. This basically means that x is less than 8 and I will highlight that word and at the same time x is greater than -3. That's a weird way to look at it, right? Saying that x is less than 8, but x is also bigger than -3. Essentially what we're saying here is that x, our variable, is somewhere in between our low number, which is -3, and our high number, which is +8. So that means any value between -3 and +8 will be a solution, right? We've talked about before how inequalities have multiple answers, and multiple numbers can work for our answer here when we're dealing with inequalities. This tells us exactly where those answers are going to be. We know that because we have -3 is less than x is less than 8, that our answers have to be in between the numbers -3 and 8. So let's take a look at some examples and how to solve these. We only have two for this section. So first we have all real numbers less than or equal to 9 and greater than -5. So if I need to write that out, right, all real numbers, right, less than, let's change that up, less than or equal to, less than or equal to 9, and greater than -5. So greater than -5, right? So what that means is my high number is 9, my low number is -5, and so x has to be less than or equal to 9, but it has to be bigger than -5, right? I have my high number here, I have my low number here, and x is in the middle. Also, I would like to point out here that we are always going to use either a less than symbol or a less than or equal to symbol when writing compound inequalities. And I know that that's weird, but the reason is behind it is because we could say x is less than 9, x is greater than -5. Remember, we've talked about this piece before, how sometimes if we want to flip around inequalities like we're flipping a pancake, we could rewrite x is less than 5 as -5 is less than x. So we have that piece right there, and then we have this piece right there, and they overlap. So it just takes a little bit of timing. Again, remember, if it's easier for you, don't worry about all that, right? Just worry about this, right? We have a high number of 9, we have a low number of 5, and x has to go in the middle using less thans or less than or equal to signs. Okay, so let's look at our second example. So sometimes you might get word sentences to translate. Sometimes we might get inequality signs. So again, looking at this graph, we have a low number of -3. We have a high number of 2. So we know that x has to be between 2 and -3. An open circle at -3 means I use a less than sign. A closed circle at +2 means I use a less than or equal to sign. And now you've created your inequality. And that's all we have to do on those, right? We find our low number, we find our high number, and we use the appropriate sign that goes with it. It's either going to be less than or equal to every single time. So hopefully this has cleared up how to solve these problems, and your practice is going to help you solidify that. But as always, if you have any more questions, please reach out to me. I want to help you out. Reach out to me and let me know.